In the previous video, we talked about relationships. In this video, we're going to talk about associative entities, which are bridge or intersection entities, and they exist because of a combination of a relationship and an entity. So when do we create an associative entity? Always when we see many-to-many relationships or ternary relationships and beyond. Other characteristics of an associative entity is that they all have their own unique identifiers and other attributes that pertain to them as well. And they additionally have an independent meaning. So let's look at an example of an associative entity that would occur from a binary relationship. So we still have this employee to course relationship that we looked at previously. An employee completes 0 to many courses, and a course is completed by 1 to many employees. Additionally, we have this box that indicates there's an attribute of this relationship. So what is date completed? Is it an attribute of employee? No, unless you're talking about birth date, but that's something completely different. Is it part of course? Again, no, unless you're talking about when the course was actually completed and ready for people to actually take. No, we're talking about the date that an employee completed a course. So this is an attribute of the relationship. How do we convert this to an associative entity? What we do is we take the employee and course entities and model them the same. Then we're going to take the attributes of the relationship and we're going to model them as a separate entity called the associative entity. So here we'll call it certificate, and we'll put date completed as an attribute inside of the associative entity. Also notice that it has rounded corners. Then what we're going to do is we're going to take the cardinality that exists here and we're going to put it on the opposite side. We're going to take the cardinality that exists here and puts it on the opposite side. So basically it reads like this. A course has 1 to many certificates just as a course has 1 to many employees. An employee receives 0 to many certificates just as an employee completes 0 to many courses. Modeling associative entities in a ternary relationship would look like this. So we see this relationship that exists between these three entities, with shipping mode and unit cost being an attribute of the relationship. Again, shipping mode would not make sense to apply to any of these. Unit cost could apply to possibly part, but we're talking about the cost to ship that particular part on this particular freight or whatever we're going to ship it with. So we're going to model everything the same, the original entities, and then we're going to include this associative entity called shipment. And then shipping mode and unit cost become attributes of this entity. Now you'll notice that 1 to many, 1 to many, and 1 to many are all now connected to this associative entity with mandatory 1 connections to the original entities of this relationship. I will say that going back here, if you don't know what to call this associative entity, an acceptable name would be to use the two outside entities. So this could be called employee course instead of certificate. Alright, so now let's look at this learning activity. I want you to try this on your own. Convert this binary relationship to an associative entity. So pause this video, attempt this on your own, and come back to compare your answer. Alright, welcome back. So here we see we have a product and an order. The product is included on 0 to many orders, and an order has 1 to many products, with ordered quantity as an attribute of the relationship. So the way we'd model this is we'd have 3 entities. We're going to have the product entity, which includes all the attributes that are listed below it. I'm not going to represent it just so I don't have to write them down. And then we have the order entity, again with all of its attributes, order ID and order date. And then what we're going to do is we're going to slap an associative entity in the middle with an ugly rounded corners. I'm just not very good at drawing that apparently. And then we connect these together. Now what do we call this? Well, we could call it product order, or let's call it order line, meaning that each line item on an order has a product. And then attributes of order line include ordered quantity, which I'm going to abbreviate as QTY. Then we're going to model the cardinalities. So a product is included on 0 to many orders, and an order has 1 to many products. Then we have the mandatory 1s on both sides, and then we also need to name these relationships. So an order has multiple products, and a product is included on an order line. And that's how we would do this particular learning activity. So let's look at another example. I want you guys to try this on your own as well. So what you'll need to do is identify where you would need to include associative entity. This is based off of our previous learning activities. And then identify the attributes of the relationship that would exist. Then convert the relationship to include an associative entity. So pause this video and complete this on your own, and then come back to check your answer. Alright, welcome back. So where did you identify that we needed an associative entity? You probably noticed that we have a many-to-many relationship here, and so we'll always need to model it as an associative entity there. So I'm going to create my ugly associative entity, and I'm going to call this statistics, meaning player statistics during a game. So we're going to say that a player has zero-to-many statistics, and a game has one-to-many statistics. Then we're going to have the mandatory ones on the outside, and then we give these a name. So a player plays in a game, so they play in a game, and then a game has many players. And then as part of the attributes of statistics, we could have shots, we could have shots made, and then based off these two, we could have a derived attribute of field goal percentage. And then we could have also steals and rebounds, etc. So you kind of get the idea of the attributes that could exist. As far as the unique identifier that could exist, we could just take in the player ID and player name and make these as attributes of statistics. And that way we'd have that identifier that we need for that particular entity. Then we get rid of this relationship and we should be good to go.